What is happening, Mark Bare Naked Willie? How are you, my friend?
Happy BS Building Science Friday live, Dave.
I love it. This is going to be a great show. As you can see on the screen, everybody, we have Anthony Pack. We are going to be talking about carbon. And I don't think we're talking about carbon footprint. We're talking about carbon disasters potentially here. At least that's what we had from our last show. So with that said, I am looking forward to today's show. And Mark, you're looking mighty warm. Where are you right now?
I'm at the recording studio for U.S. Engineered Wood, and I just happen to feel like being green today. So, yeah, I got that on, and I like the background you got. You got the purple and the blue and the silvers, very tranquil.
Some what is that, like T511 paneling behind me? I'm really rocking it today, brother.
I know you have some IBS stuff coming up. For those of you that are first joining us, can you let us know whether you're on Facebook, LinkedIn, YouTube, or Twitch?
Twitch.
And with that,
a thumbs up. Why are we on Twitch, Mark?
Because the cool kids are ready to be technical with their buildings, and that's what building science is all about.
That's right. That's right. We had Interspace Modular on this week, and I said, why are we on Twitch? He goes, because we love Twitch. And we do. We want all the young people. We're trying to bring people into our environments because that's what we do. So listen, everybody, at Dave Cooper Live, we're bringing you the people and the processes that are building it better. Our guests and topics include experts in building systems, building science, building codes, and the tech used to build it better. And today is no different. We are seeking out the best and the brightest in construction and discovering all of the innovative ways that buildings come to life. Mark, today's going to be a lot of fun. There's already a ton of people signed up and viewing what we have going on. You know what? There's a new fish in the fish tank.
There's a fish in the fish tank, and I'm going to leave the audience with something I'm going to say 3 times today. Today's about questions. This topic is engaging. That's why you came here. And Anthony is great at answering questions. Please be inspired and challenged by what he says. Put your questions on there, whether they're simple or difficult, because we aim to answer them today. And I'm ready to go to the fish tank and do a little surprise like we do on BS Friday, Dave.
Oh, fish tank surprise. I wonder, are we catching a tuna, a marlin? What is this one? I mean,
a helicopter.
A helicopter. All right, let's bring him in. What is happening, Sean Saint No More? Your mic is muted.
You got a mitten on
your
mic.
Sorry, guys. I got excited. Got excited. Good to see you guys. This is a great show, and I know he's got lots to talk about, so let's just get right into it. So embodied carbon is the phrase today. And interesting enough, like last year, it was kind of like a big word in construction. Lots of people were talking about it. But this whole thing kind of comes back from the life cycle analysis, which is something that I got involved in about 15 years ago. And this is actually how I got to meet this fine young lad. 2 years ago, I went to a presentation from one of our other friends, Ryan Sawchuk, who's been involved with the Athena group, which is kind of like the kind of starter part of the life cycle analysis group, looking at those details. And so Anthony Pack was there, and he gave a great presentation, and I knew this was a smart cookie. He understands this stuff and actually presents really well, and you're going to see this, shortly. So I met him and afterwards talked to him and wanted to know more about him. And he's like, Sean, well, come out to my event that I'm having next month. And that was the Embodied Carbon Catalyst. And that is now turned into the Carbon Leadership Forum that he's operated and is involved in. And so if you guys are ready, let's switch it over to this amazing gentleman who, honestly, he knows everything you need to know about embodied carbon. And just to be clear, too, is, embodied carbon is looking at the energy required in the building process of our buildings. And then we have the operating energy. And so to kind of, rephrase it, we kind of like to say that it's upfront embodied carbon because we're focusing in that early part of the buildings. And Anthony knows everything you need to know about upfront embodied carbon.
I love it. I love it. All right, let's bring Anthony in. Anthony, what is happening, my friend? I'm going to move you to the top of the screen here because that's where you deserve to sit right on top of Mark's head.
Well, hey, it's a great intro for a great guy. And honestly, you are the man in person when it comes to this stuff. You just know it all. And everyone relies on you for this.
Hopefully I can answer your questions. I don't know. I don't know if I know it all, but
you know how to direct us and get us started when we're trying to figure out how do we reduce our carbon footprint when it comes to building. You provide us with great guidance.
Yeah.
Hey, and there it is. There's that carbon footprint word again. We're going to have to define this, break it down. Is it a carbon footprint? Is it a carbon disaster? As Mark and I got into it last Friday. But I think as we move on to this, Anthony, we ask all of our guests, so everybody knows who you are, to take a few minutes. We want to know everything about you from the moment you were born to this very moment in time. And do not leave out any of the good stuff from the hospital, or we'll call your mother. You got 3 to 5 minutes to do it. Go for it, Sean. We'll come back to you at the end.
That's hilarious. Thanks. Yeah. So I guess a little bit about myself. I'm an engineer by trade. I'm a mechanical engineer. I worked for a couple of years in the HVAC side of things. I also did my master's degree in a field called industrial ecology, which within that field, one of the things that I learned a lot about was life cycle assessment. So I did my master's in Norway, where there were a lot of kind of academic researchers working on this. And that was back in like 2010. And it actually took a few years for the industry to kind of catch up. But when it got to a certain point where I felt like, okay, like there's actually the industry starting to pull for this. City of Vancouver's changing some policy. There's some changes with LEED. That's when I decided I could kind of shift fully to focusing on life cycle assessment. So that's what I do now. I have a company called Priopta, which is a consulting firm that just focuses on doing life cycle assessments for new construction projects. So somewhat similar to like hiring an energy modeler on a design team. We basically analyze the other half of the equation, looking at the materials and looking at the carbon emissions associated with those materials. So that's the company. And then I also started up a group called the Carbon Leadership Forum Vancouver chapter. So it was the first local hub of the Carbon Leadership Forum. Basically, we were bringing together a lot of industry stakeholders, Sean included, at some of our initial events. So structural engineers, architects, developers, the wood industry, the concrete industry, like all the relevant folks that have some say in what materials get used in a building. We bring them together, and we have had quite a few events focusing on all sorts of topics relating to embodied carbon. Now we've transitioned online, so we're doing mostly webinars and stuff due to the pandemic. Since we started the first local hub in April 2019, now there's about 25 cities that have started up local hubs as well. So it's been really exciting to see. And so as a regional hub director, I help support a lot of the local hubs, especially in Western North America and in the Asia Pacific region. So that's a little bit.
Love it. So before we get started, Mark's already ready to go. I see he's got his roller skates on and he's got his Superman cape. Yeah. Before we get started, Anthony, we got a ton of people tuning in, and not everybody is really that familiar on what carbon is all about. Sure. And I know Sean kind of did a good job of explaining it as well. But in your own layman's terms, if you met somebody who never understood this stuff or never knew anything about it, how would you explain it to them? And then let's jump into the details of this.
Yeah, so I get into this a little in the presentation, but basically in the context of buildings, when we're talking about embodied carbon, we're really referring to all the emissions associated with the materials. So think of all the materials that make up a building, all the concrete, steel, wood, glass, insulation, etc. For each one of those materials, there's a whole life cycle impact associated with it. So when we're talking about life cycle, I mean like everything from extracting those resources, like harvesting the timber, mining the resources, mining the metals, all the way to like the manufacturing and processing, and then into the construction, and all the way to end of life. So, do you landfill those materials? Do you incinerate it? So there's emissions associated with all those different steps. And so we basically look at quantifying all those emissions. And it's, you're looking at the supply chain of all the materials that go into the building and quantifying the emissions from that. So that's embodied carbon.
Love it. All right, Mark, I'm done. Go ahead.
I want to get right into the presentation. I know people are here to see it, so if you're ready, Anthony, take it away.
Great, thanks. Okay, let me share my screen.
Sean's still in the background. We can talk about him. He can hear us, but he can't say anything. You guys want to talk about Sean for a while?
I want to talk about existing buildings, and Sean and I would talk every night.
I love it. I
All
love
right,
it.
you guys can see the slide properly?
Yep, we got you up and going.
All
We got
right.
the first page up.
Let's get into it. So this is a shorter version of my presentation slide deck, but I'm going to be covering a bit about why embodied carbon matters, embodied carbon versus operational carbon, how they compare, and then also some of the policies and standards that push for embodied carbon. So the first 3 sections I'm going to try to cover in about 15 minutes or so, and then we'll have some Q&A. And then I'll get into the second section, which looks at how do you reduce embodied carbon. And I'm going to dive into each of these individual materials: concrete, steel, wood, aluminum, glass, insulation, refrigerants, mechanical, electrical, plumbing, and interiors. So, but yeah, I definitely invite all the questions that you guys have. So please type those in. All right. So why embodied carbon matters. Just to reiterate what it is, we're talking about the emissions from all the construction materials. And that's embodied carbon, and throughout all the life cycle stages. So these images represent everything from resource extraction, transportation, manufacturing, construction, operation, end of life. So we're quantifying all of those emissions. So how big is the problem? If you look at global CO2 emissions annually each year, about 28% of global CO2 emissions goes towards operating all of the buildings on the planet. So think of all the buildings, what it takes to heat and cool and operate those buildings. That's 28% of the CO2 emissions. A further 11% goes towards the embodied carbon. So that's all the new construction that's happening each year and the major renovations. So the materials associated with that new construction, that's 11% of global CO2 emissions. What's interesting is if you zoom out of even outside of the construction industry and you just look at 3 of the key materials that are oftentimes used, concrete, steel, and aluminum, combined, they make up almost a quarter of global CO2 emissions. Obviously, we don't use all the concrete, steel, and aluminum in just only in the building sector. We also use it in infrastructure. We use it to make, build bridges or build cars, and et cetera. But why I point this out is because if we can influence the supply chains of some key materials within the construction industry, that has repercussions beyond the scope of our industry. We can influence how infrastructure gets built and the supply chains of that, or of auto manufacturing or whatnot. So, and we're building a lot of buildings. And so if you just look only at the new construction that's taking place over the next 30 years, about half of the emissions associated with that new building stock over the next 30 years is associated with embodied carbon, with the other 51% on operational carbon. And that's particularly significant because we're building a lot of new buildings. It's essentially equivalent to, we're projected to double all the building floor area that currently exists over the next 40 years. And to break that statistic down in another way, that's equivalent to building an entire New York City, all the buildings that exist in New York City, building that floor area every month for the next 40 years. So obviously, if we're going to try to hit any of our climate goals, it's going to be really important that we actually address embodied carbon as well, not only looking at the energy use and the operational carbon.
Anthony, is that number you gave, is that the residential and commercial construction industry combined?
Yeah, all buildings.
Okay.
Yeah. Okay, so then embodied versus operational carbon, how do you compare them? So the key metric I'm going to look at is kilograms of CO2 equivalents, that's the little e, per meter squared of floor area. So that way you can kind of put the 2 metrics on a similar plane. So when we're looking at a typical building, let's say hypothetically this building lasts for 60 years. These yellow bars represent the operational carbon. So that's the emissions associated with operating, the energy use and the operation. So historically, this is what we use energy modeling, or not historically, this is what we quantify when we're using energy modeling, right? And this has been the main focus of the green building sector for a long time. But also for a long time, we've been ignoring the embodied carbon, which is these red portions of the bar. So, up front, before the building is even in operation, there's all the materials that go into that initial building structure and envelope. And then there's also the replacement and maintenance. So over time, we're replacing these materials. So we account for that. So for certain components, if they don't last the full lifespan, we account for that. And then also there's a pulse of emissions at end of life. And so to quantify that, we use what's called life cycle assessment, or LCA.
question on that for the life cycle assessment. Like you said, you're accounting for some of the materials to be replaced because they have an end of life.
Yeah.
Is there what's the metric for that? Is that determined based on each product?
Yes. Yeah. For each product, there's a certain assumed service lifespan. And so for many of the software tools that we use, they have default assumptions for each material category. And in some of the software tools, you may be able to override those assumptions. So if you have better data or for your specific building, you think, it's likely to be replaced more often or less often, you can account for that for every component of the building.
So obviously, Anthony, I like to dive into the past science side. So is it safe to say if buildings are designed and installed in a more durable and resilient fashion, that their life cycle assessment obviously changes? And since we need so much square footage area to be produced, we don't have time to do it twice. We need to do it for a longer duration on the onset.
For sure. Yeah. I mean, anything that you can do to make a building more durable and longer lasting, that definitely contributes and like it improves the embodied carbon side of the equation. I will note that oftentimes if you look at what's the reason for a lot of demolition, it's oftentimes not due to just purely performance reasons. A lot of times there's economic reasons, like you're going for rezoning, you're trying to build like a much higher, taller building or a different use case. And so that also contributes a lot to it. So oftentimes it's not that the materials are giving out or like the structure is giving out. So there's different aspects to that equation, but yes, for sure, the durability and especially of different components that maybe wear out quicker within the lifespan. Of course, yeah, you want to reduce that.
I knew you were going to say yes to that, but I wanted that topic to be.
Thanks for the easy question.
Push forward, and you added another layer. If the building is designed to have the aspect of change and future use, right?
Yes. Yeah.
Now we're not destroying because we want to do things for a different economic reason.
Exactly.
Dave, as you would say, we're not creating a carbon disaster.
Not yet. So, Anthony, I do have a question before we keep going, though. The data that you collect, how do you get this data? Like, where does this all compiled when you're designing buildings or looking at buildings to figure out what that carbon footprint is? I mean, the graphs are great, but how do you get to those graphs is kind of where my mind is.
There are different software tools. So within lifecycle assessment, there are certain software tools that are used for doing lifecycle assessment in general. So even just outside of the building sphere. So for individual products or anything like that. And so there's this, and then they connect to a certain database. And so there are databases that are regionally specific and that look at, for example, they're considered what's called like a background data set, a life cycle inventory data set. So for example, what is 1 kilogram of aluminum from China or from Canada on average? So there's like inventories of those types of emission factors. So it's not like you're going out and fetching that data from scratch each time.
Right.
But so in the context of buildings, there's another class of software that's specifically for buildings. And so they're designed with all the data, all the kind of common construction materials that are in buildings. And so you're basically doing quantity takeoffs for your building. So looking at how much, wood, steel, insulation, et cetera, that you're using, and you're mapping that to a database that has a lot of that underlying data. Furthermore, there's a thing called environmental product declarations, EPDs. So this is where manufacturers they essentially have a life cycle assessment done of their supply chain. Okay. And then they're able to produce a third-party verified document that says per meter cubed of concrete, this is what the emission intensity of my product is. And so some of the whole building LCA tools also draw on that type of data as well.
Got it.
Yeah.
Love it.
All right. So, so when we're doing life cycle assessment, most people are mainly focused on the carbon side of the equation. And so there's an environmental impact category called global warming potential, or GWP. So if you see that acronym, that's what that means. That's what we're referring to when we say embodied carbon. But LCA actually looks not only at carbon, there are actually other environmental impact categories as well. So in North America, we look at things like acidification potential, eutrophication, smog formation, depletion of non-renewable energy, and ozone depletion. So in North America, we mainly focus on 6. In Europe, there's like something like 18 other impact categories as well. So, but just so you know, like LCA also, yeah, the GWP is what most people are focused on when they mention embodied carbon. And so when we're talking about life cycle stages, these are, there's a formal definition for each of these stages. So module A is looking at the upfront carbon. So everything from resource extraction, transportation, manufacturing, and then transportation to the construction site, and then emissions associated with construction and installation. That's A1 to A5. Those are before the building is in operation. That's those stages. And then B is the use phase of the building. So I'm
going to comment on the first ones.
Yeah.
So for a lot of people that came into this world via, let's say, the green or sustainable market, that's why you saw with the movement of the USGBC, you saw that you had the 500-mile radius and the 250-mile radius. They were inclusive of it, but these data metrics were not something that the project managers or consumers were involved with, but that was the overlaying rationale of saying locally we could reduce the carbon by keeping it close. And if you don't have the product close, find an alternative that is.
Well, that's actually a good point that you bring up, because part of why life cycle assessment, I think, is a powerful tool when we're thinking about how to solve some of our environmental challenges, is that it takes a big, like a wider lens at looking at this whole picture. So historically, actually, you're pointing out the right things. We tend to focus on one aspect, one attribute of a product. Like, what's the transportation distance? Is it local? Is it close by? Or is it renewed or recycled? And what's the recycled content? But that's not actually the whole equation. So actually, when you do an LCA for many of the construction materials, it turns out that oftentimes the transportation is not actually the biggest driving factor. What tends to matter more is the production technology. So for example, I'll get into this later, but like how you produce the steel or the concrete, that can matter more, or even what the electricity grid carbon intensity for your state or for your province and where that material is produced, that can drive those factors potentially much more than something like transportation distance. And so it's by doing this, we actually have a broader view, and we actually look at where are the emissions coming from, and it's different for each material category. So it's a bit more complex than that, but
that's exactly right. Before we had a generalized matrix, right? And now we have a deep data mine that says the contrary on some of the rules and processes that we worked through before. So that's why this is indicative of what we need to be strategizing with.
Exactly.
So the life cycle is what I'm hearing you. Before, it used to be based on mileage and transportation, right? That was the day. Within 250 miles, you get so many points. 500 miles, you get so many points in data. But what I'm hearing you say, Anthony, is that it starts at the manufacturing level, maybe even further back in getting the raw materials and where they're coming from. So you look at that whole life cycle of a product to determine the stages.
Exactly. Yeah. So that's what LCA is that you're looking at all the life cycle. I think historically, like the green building rating systems, they might award certain points, amount of points, and they still do on certain attributes of the product. But what I'm saying is, to get a more holistic picture, you really want to look at all the life cycle stages. So, there's the use phase, and then there's also the end of life stage, right? So for any given material, how is it deconstructed, transported, waste processing? Like, does it go to a landfill? Does it get recycled? That all affects the carbon side of the equation. Does it get reused? So when we're reporting LCA results, we're typically looking at A to C as the range of results. That's the primary set of results. And then we also have a thing called module D, which is looking at benefits and loads outside of the system boundary of your building. So for example, if you're trying to account for the benefits of reuse or recycling, that impacts like a future product potentially, right? So how do you assign the benefits of that? And so sometimes we actually report this information as supplementary information, but the main set of the results is here. So that's on the materials. And then you'll notice B6 is operational energy use or operational carbon. That's what you would have gotten from energy modeling. So basically, if you marry those two, add those two pieces together, the LCA and your energy modeling numbers, that gives you a more holistic picture on what's your whole life carbon of the building. So like the total carbon footprint, so to speak, of the building.
A lot of this really echoes the cradle to cradle, right, programs that which is, but your approach is certainly different. You want to stop for a question, Anthony?
Sure. Yeah, we can. Yeah.
One question or several, because it's lit up. All right, let's get into this.
Oh, that's right.
All right, everybody, listen, we are going to go to questions, but first we are on LinkedIn, YouTube, Facebook, and Twitch. Please pound that like button right now. We'd really appreciate it. And if you are not following Anthony Pack on LinkedIn, go and follow him. You're going to learn important. All right, let's get into it here. What do you think, Mark? Oh, Mark. Mom Willie's here. What's happening, Diane? Good to see you, Miss Willie. Thank you for joining us today.
I hope you're learning from Anthony, just like the rest of us, Mom.
I love it. I love it when she tunes in. Hey, it's BS Friday. Buzz Holitzer. Hey, buddy.
If you notice, Buzz put Friday with the PH.
I know you're starting this global trend. I see it happening. All right, Paul Eck, joined by LinkedIn, by the way. Could Mr. Pack comment on BIPV, building integrated photovoltaic? Does the PV have a big embodied carbon from mining? Other comments?
Yeah, so PV does have an embodied carbon. I mean, if you think about it, any renewables have an embodied carbon footprint, right? Like even wind turbines, because there's materials going into it. And yes, photovoltaics do have there is an impact to that. The question is, does the benefit on the operational side offset, or like, how do I say it? How big is the scale of that impact compared to the benefits on that it saves in terms of the operational side? And that gets into a more interesting conversation. So the equation changes depending on what state or province you're in, because you're comparing against the background the carbon profile of your given location, right? So for example, I actually have some slides. You know what, maybe I'm just going to jump back and forth between some slides, but
all right,
let's look at, for example, the carbon footprint of different provinces in Canada. So British Columbia is like about 10 grams of CO2 per kilowatt hour, because we have a lot of hydroelectricity, super low embodied carbon, super low carbon intensity for electricity. Same with Ontario, you know, around 20. But Alberta has a lot of natural gas and coal, and so it's 800 grams of CO2 per kilowatt hour. So, for example, if you're installing photovoltaics, the benefit that you're offsetting relative to the grid depends a lot. So, like if you're in British Columbia, it already is a fairly clean electricity supply. So, what's the actual relative benefit? Some people make the argument that maybe this you should not be comparing against the average carbon intensity of your electricity grid, but rather the marginal intensity. So there's also marginal grid factors as well. So for example, in the marginals, like outside of base load, like do you need to fire up a natural gas peaker plant or something like that? And if so, what's the carbon profile there? And so some people may say, oh, you should actually compare it against that, and that could be the relative benefit. So generally speaking, I think PVs definitely are very low carbon in the grand scheme of things when you account for all of this. But the specifics of that equation depend a lot in terms of how you're comparing the grid mixes. This is a similar chart for United States as well. So you can see, I've actually taken all 50 states, graphed them by carbon intensity. So you can see, you know, at the highest, it's around like close to 1,000 grams of CO2 per kilowatt hour. And at the lowest end, it's closer to like 10 or 20, right? And it's really a function of what's the grid mix. So, you know, you have black as coal, brown as natural gas. So you can see at the higher levels, when you have a lot of coal and natural gas, you're closer to that 1,000 range or in that upper range. And then as you get more renewables, you know, solar, wind, biomass, typically these renewables have, let's say, lower than 50 grams of CO2 per kilowatt hour. So when that becomes a bigger portion of your electricity grid, you get driven lower as well. And
how in the world does Minnesota have so much biomass? Where did that come from?
I don't know the specifics of the situation for every given state. I just took like the EPA's data, eGrid, from 2018, and I graphed it all out. So this is the carbon profile. And then just to finish this off, the red graphs show you the net generation. So you can see like how much electricity is generated each year. So obviously Texas is a very big state, so it produces a lot of electricity. you know, Vermont can be really low, but they produce very little electricity in the grand scheme of things. So it just gives you a sense of the picture of the whole states. And then if you want to see one more, this is the average, national average for different countries. So you can see, you know, like Canada's like around 150, but when you break it down by province, you have a bunch that are like, you know, 20 or lower, and then some that are like around the 800 range. So they average out. So that this obviously affects a lot on the operational carbon side of the equation, but it also affects your embodied carbon depending on where you're producing the materials. So just kind of circling back to that point.
I normally fall asleep when someone puts graphs on. I look at them as a flight of stairs to the Hancock.
Well, you're going to fall asleep a lot today.
But I tell you, what comes across in your graphs is a clear picture, and you bring the passion to it, right? This is not a topic that everyone could digest. That's one of the reasons why it works. And bless your heart for your style of bringing this forward.
Thanks.
No, well, you know what? You add a whole lot of enthusiasm to it, and you explain it very easy. Mark, I think I'm getting some feedback. Might be from your mic, actually. Just letting you know. So, all right, Auntie, let's keep getting into some questions here. We got we're into this 35 minutes already. Time flies by. Let's speed round through a couple questions. I know you have a lot of details to get through.
I'm just gonna jump around. I don't have to get through it exactly.
Yeah, it's okay. It's all right. This is what it's all about, you know. But we definitely want to reach out to everybody. So let's go back up here. So we already did this one. Asked if it's recorded. Let's go. Paulak had a follow-up question. Heliogen, concentrated solar for steel and concrete. I'm assuming that's a product that he's putting up there. Henry Mickelberg says, screenshot everything. Kathy Ayler says, so is embodied carbon the emissions required to produce the materials and build the building, as well as what's stored in the, e.g. wood materials that they sit statically in the building once built?
Good question. I have a slide on this later. So this is actually a point of confusion for a lot of people. So for example, you hear a lot of comparisons between, like wood versus concrete, right? And typically in our LCA studies, wood does show much lower emission profile compared to, you know, concrete or steel structures. But it's important to like look at what are the assumptions in that study. And so you're pointing to a good point around like, are you accounting for just the emissions associated with, for example, harvesting the wood, transporting it, manufacturing, processing, etc.? Or are you also accounting for, are you giving some benefit or some like negative credit for the storage aspect of the carbon? Because the wood obviously has some carbon content stored within it. So how do you deal with that? It actually is a fairly complex topic, and different software tools quantify this in different ways. The conservative end of the assumption is to not account for this, not give this negative credit for the carbon stored in the wood. But some studies do also account for it. And it's not to say that it's the right approach or the wrong approach. I think there's a lot of different opinions around this. But if you want to be on the conservative side, you don't account for it. If you do, it's important to understand how they quantify it. So some people just try to estimate the carbon content that's actually in the wood, and then multiply it by -1. And so sometimes that's why you see some of these negative values, or it's carbon negative or carbon storing from the wood. But then some others may account for it slightly differently. So for example, within Athena, which is one of the software tools, they don't typically present that in their main set of results, the A to C results, but they put it in module D. If you recall what I said about like it being outside of the system boundary, they put it in that area. And they might have a complex set of assumptions around end of life. So they're looking at, you know, in reality, the carbon is stored in the product for, you know, a number of years, for 60 years or whatnot. So that can be a really good case. Like you definitely do want to store that carbon as long as possible. There is a carbon benefit, or a climate benefit to that. However, what happens at the end of life? So for example, if that goes to the landfill, what portion of that wood decomposes and then turns into methane or whatnot? So there's a complex set of assumptions around that. And so this is really just temporary storage of the wood. So anyways, that's a long convoluted answer to look into the specifics of those studies to see whether or not they account for it. Sometimes they do, sometimes they don't.
Love it. Love it. We got a good old Andrew Seeley joining us. What's happening, Andrew? Always a pleasure having you join us every day. Thank you so much. Martin Torres basically answered the same question to Kathy. I just want to give a quick shout out. Thank you, Martin, for echoing Anthony's opinion on that and facts. And now we have George Sullivan. EC3 is the model we use. Love it. Love it. Love it.
I can share something about EC3 as well. So EC3 is actually not a whole building LCA tool in and of itself. So EC3, for those that aren't familiar, it stands for Embodied Carbon Construction Calculator. That tool compiles all the publicly available, or as it tries to compile as many of these publicly available environmental product declarations from different suppliers as possible. And so its main intended use is more for at the tendering phase, like when you're comparing between different concrete suppliers, what's the relative emission profile, but it doesn't analyze those other environmental impact categories that I mentioned before. And it's not like a whole building LCA tool in and of itself, but it is a valuable tool.
God, your brain, do you sleep at night, man?
This is my world, man.
I love it. I love it. I love it. All right. Paul Ack had another follow-up, and then we're going to move on to some other folks.
Sure.
He said, so solar shipping would reduce the carbon embedded in overseas aluminum?
So, I mean, I'm not familiar with solar shipping, but yes, it's first off on the transportation aspect, there are big differences. People tend to look at kilometers, but it does, or whatever, miles of transportation distance, but it matters what mode of transport it is, right? Road transportation is much higher impact than shipping is. So relatively speaking, shipping is the lowest, then like road transportation is a bit higher. Obviously, if you're like flying things over, that's going to be much higher. So yes, could you reduce the emissions from the shipping? That would make a difference, of course. And so that would be valuable. However, again, for most construction materials that I've looked at, oftentimes the transportation component is not a very significant percentage of it. It might be like less than 5% sometimes, with the exception of maybe CLT, because the wood is already fairly low impact to begin with. So as a proportion, the transportation ends up becoming a bigger slice of it. And plus, oftentimes we don't have CLT manufacturers that are very close, depending on where you're building the project, that can affect things as well. Or if you're shipping it from Vienna or like Austria, that's for sure going to impact the transport.
Maybe this is going to become cyclical, Anthony, and we'll be building large wooden boats with sails, and we'll be carrying our goods by wind power over the seas.
Love it. Love it. All right, here we go. Here we go. Joseph Haggerton. Mark's question seems to indicate a compounding effect of emitted carbon from generated waste of less durable products.
Compounding effect of emitted carbon.
So I think he's pointing to the fact of if you use products that have to be replaced more frequently, right?
Oh, yes.
It's compounding the problem. And then that goes on to say, if you're making that durable and certainly tighter, more insulated structure, you're having an effect on the operational carbon as well, right? We're requiring less energy to provide comfort and whatnot to the residents, right? Because as we learned very clearly last week from Susan, our buildings are for people. So all of us are doing this behind the scenes, right, for the betterment of buildings, but truly for the betterment of people. And we can't forget that we have to sit at a table, and we want the stars not always directly above our head.
Sure.
Why not?
Well, at times it could be raining. In British Columbia, the last 3 weeks it's been a little bit cold, right? So you might not want to sleep under the stars during those days.
Love it. I love it. All right. Tony DiCarlo, recycled steel or timber for home structure. Which one is more carbon efficient over a life cycle?
Wow.
Recycled steel. Okay. So recycled steel. Let me, one sec. So steel. I'm just jumping all over the presentation, but it's perfect. This is a good launch.
You want me to put it on the screen? Tell me if you want something on the screen.
Yeah, sorry. Am I sharing my screen right now?
Not right. You are now.
Oh, I see. Got it. Perfect. So steel, there's two main ways of producing steel: basic oxygen furnace and electric arc furnace. So BOF uses less than 25% of recycled content. Mostly it's virgin iron ore going in. and it makes up about 71% of global CO2, or sorry, global steel production. So a lot of the steel in Asia is BOF. I think in the United States, about 2/3 of the steel is electric arc, and then the other third is BOF. So BOF is the higher emission aspect of steel, or it's higher emission compared to electric arc. So electric arc is typically about half. It could actually be even much less than half. So with electric arc furnace, it uses a lot of recycled steel. It's mostly recycled steel scraps, like up to, let's say, like 97% recycled steel makes up, about 30% of global steel production. This, and because it's an electricity driven process, if you think back to those graphs that I showed earlier about the carbon, the electricity grids, that affects it a lot. So for example, steel from Seattle, which has a relatively lower carbon intensity grid, that their EAF, or sorry, their electric arc furnace, like rebar, for example, or their steel can be fairly low, like much lower. It could be maybe even like a fifth of the impact compared to BOF. So yes, recycled steel does make a big difference. However, it's and it's a similar story for aluminum. For most metals, they're very highly recycled already, and so there's not enough recycled metals around to actually satisfy all of our demand, which is why the primary production still matters. So, even for your project, I definitely do, it's good to incentivize and focus on recycled content. Now, as to the specifics of that question of how does that compare to wood? I think that's a challenging question to answer. It depends on the specifics of the structure. One of the pitfalls that people have sometimes when they're looking at LCA studies is they're comparing one material versus another material, and they might look at per kilogram or even per whatever, per meter squared or meter cubed or whatever. But it matters a lot, what's the functional unit. So you have to compare these things in an equivalent basis. So for your steel structure, what type of steel structure is it? Is it I don't know, open web steel joist? What type of steel joist? How does that compare to, are you comparing that to CLT or wood frame or something? So, typically wood does come out lower, but I would say, recycled steel would make a difference. But keep in mind, it varies a lot depending on the specifics of the analysis.
Got it. I got you back on full screen here with us, Anthony. So we're going to take one more question. And I think let's hop back into the presentation. There's a lot. The questions are just pouring in. Getting to all these questions is going to be
that's fine. We can just do Q&A, and then I'll just jump back and forth to the slides.
I love it. I love it. We may end up just doing that. Let me go up here again. So, oh my goodness, man, you're a popular individual. All right, here, let's go to this one. We're going to start here. There's two of them. I'm going to put them both up, and then you can answer both of them. So, sure. Julian Bowren, hey, what's happening from Canada? Electric steel making in Ontario consumes electricity that is 90% carbon free because the source is hydro, nuclear, wind, solar, and gas for peaks only. And the primary input is scrap. So a coil of steel used to make light steel frames can be high carbon if virgin and from coal-based process, or low if based on scrap and electricity. I'll go back. I'll put that first one back up so we can comment on that first.
Well, I mean, for electric arc furnaces, I'm sure it is fairly low impact. I recall seeing a statistic that I think something like 40% of the steel production in Canada is electric arc. Yeah. So it's not as high as the US. So I think maybe about 60% is the BOF variety, and so it's not just an electricity equation then for that.
And if we want to brag about big numbers, we could always state that steel is producing much more thermal bridges than wood. So if you want to brag about big numbers, steel is a high deliverable of thermal bridges. And if you don't see the sarcasm in what I just said, then you don't understand insulation to begin with.
Are you saying steel is cold?
I'm saying I don't care how much insulation you put into a steel wall, it doesn't do diddly squat for comfort.
I love it. I love it. I love it. All right, we're going to stick to questions. Let's keep going before I round Mark up. We'll never get out of here. Yeah. We'll never get out of here. All right, Paul X said, be careful on that nuke, mining, disposal, etc. So moving on.
Not my backyard, Paul.
Let's see. Also, let's give Kathy some love here today. Also, human resource elements, avoiding mining companies that use child labor, not carbon related, unless the company is avoiding fossil fuel powered machines by using human manual labor, but so crucial to be aware of. Now, that's not something you hear every day, right? Nobody would even think of that unless you live in one of these countries that's doing this.
Yeah, well, actually, that's a good point. So yeah, you're right. Like life cycle, first off, life cycle assessment is not like the end all be all, right? It is still only one limited lens. It's a more holistic lens if you're talking about carbon or some of these other environmental categories. But of course, it doesn't address, for example, social equity and some of those types of issues. So there is actually an effort. I know of some people that have created what's called social LCA. And so they're trying to like apply the LCA methodology, but looking at social factors. So like things like forced labor or whatnot, especially in some of these other countries that where those practices may be more prevalent. And so I know there's a thing called the Social Hotspots Database. I'm not sure if it's been, at least back then, that's what it was called. And there were some efforts on that front. So if you're interested, just search up that. And so I've never seen it deployed in industry or in typical practice, but just know that there are some folks that are kind of engaged in trying to apply that methodology to this.
I like to bring a positive side to everything, and there is a positive side to child labor, and that is they eat smaller lunches, right? So I say that as a funny joke, but it's true. A lot of the ways in which countries have begun to come together as communities is by working in orchards and by working the land and by working together. And so there's nothing wrong with a child working. It's the manner in which it's handled, right? We still have to talk about justice. But I mean, I think a lot of us grew up working as a young child, so there is a positive side to that.
Yeah, for sure. That's interesting. Kathy Ehlers, biomass, corn, ethanol, and is that MN? Is she talking about the state, I guess?
Yeah, she did the research on Anthony's line about where the biomass large number came from Minnesota. So she's subscribing that it's Minnesota.
Yeah, I love it. All right, Kathy, thank you for tuning in with us. Tony Hulub, great conversation. LEED did shift the credits in V4. Now better accounts for holistic decisions making regarding material selections. Still work to be done, but heading in the right direction.
Always go beyond, right, Tony? Always go beyond.
Yeah, actually, I can. I have a slide on that. Maybe if you want to pull it up.
Yep, I'm ready for you here. Give me 1 second. Got it.
So this was like looking at some of the policies and certifications focusing on it, but that was a good point around LEED. So LEED version 4 did assign some more points associated with it, but then I would encourage anybody pursuing LEED to go for version 4.1 so you can substitute on individual credits. So in this version 4.1 of the standard, you can get up to 5 points for whole building LCA. So what's great about this is previously the way it was structured was that you get 3 points for reaching a 10% reduction on a whole building basis. So like you have a baseline building, you show you made some design decisions to reduce the embodied carbon by 10%, and then you can get 3 points. There's more particulars to that. I won't get into the specifics, but previously that was it. And so if you didn't hit the 10% threshold, you didn't get any points. And so it was actually perceived as a risk to a lot of project teams because they didn't understand LCA and all that stuff. Right. So in the update in the version 4.1, what they now created is that you get 1 point just for doing the LCA. So you don't get penalized, you'll still get some credit, but there's a progression. So 5%, 10%, 20%. And plus, depending on where you are, that might unlock a regional priority point as well. So it can be a really worthwhile part of a LEED strategy for a lot of projects if you are going for LEED. I've been on some projects where they were going for LEED Gold and they needed to hit that target, but they were short some points, and this was a neglected part of the strategy. So I think it should be a more prominent part for teams.
Yeah, they just had a bike rack. We're okay with that. It's interesting you have the city of Vancouver on there versus the BC step code, and that's because Vancouver does things slightly different than BC, correct?
Well, so this isn't presenting it versus the step code. So the step code focuses on energy. It's the energy step code. Right now, it doesn't do anything relating to embodied carbon. So the city of Vancouver, which has some more unique, I guess, powers at the municipal level than compared to most other cities, which allows them to do really ambitious policymaking. What they've done is since 2017, they've required reporting on whole building LCA for much of the rezoning projects, and rezoning makes up a little over half of the new construction in the city. So, but the really cool thing was actually in November of last year, they passed the Climate Emergency Action Plan. So you notice a lot of cities are declaring climate emergency. the city of Vancouver did this a while ago as well, but they also created a really ambitious plan to reduce our whole municipal emissions by 50% by 2030. So and they had outlined 6 big moves, and one of them was on embodied carbon. And so this was particularly interesting. So what they're saying is that by 2030, the embodied emissions for new buildings and construction projects need to be reduced by 40% relative to a 2018 baseline. So that's super ambitious. And the way they're going to phase this in is basically this year, they're going to be updating that rezoning policy. So requiring at least a 10% reduction. They actually haven't finalized the target, but they're basically going to progressively step it up towards 40%. And that'll cover all the new buildings in Vancouver by 2030. So it's definitely sends a strong signal to the industry. And I've seen a lot of the local design firms actually really start to focus on this a lot more because of regulatory changes like this. And a lot of other cities are starting to look at this as well.
Anthony, a phrase you might have heard over time is the greenest building is the one that already exists. Now, we know the definition of green, and sustainability has a whole dictionary of options. But the factor of that is our existing building stock is so vast and so great that a lot of times when green was introduced, people said, well, we just need to tear down all these buildings and build green energy efficient buildings. Mm-hmm. And the staggering remark of that, it never made sense to me. It's if we have a good structure in a good space and a good footprint, why are we destroying that embodied carbon, right? And why aren't we just instead creating another life for that, a more comfortable, prosperous life from that footprint?
Yeah, no, that's a really good point, and that's definitely part of this whole equation. So that's where you want to start your whole analysis, not just about like substituting one material for another material. Right. You want to start the analysis at, hey, do you even need to rebuild? Can you actually retrofit? And there's a lot of interest and efforts on that front as well to understand how that affects the whole equation. But obviously, you're preserving the structure and much of the existing, maybe some of the envelope as well. So that will obviously be favorable from an embodied carbon standpoint. Yeah.
So listen, everybody. I mean, Mark, you should see the comments, man. It's like NASA spaceships over here. The way it's going. If you don't notice, I'm listening to you, Anthony, but I'm over here trying to keep up with it. So there's a lot of people wanting us to go back to graphs and do all these things. Listen, everybody. I just put in the links. This is all going to be on YouTube. Usually takes about 12 hours, 24 hours before YouTube gets the live post up there. But please go there, follow that link, subscribe to our YouTube channel. You can rewatch all of this at your leisure as much as you want. You can share it as much as you want, whatever you'd like to do. But that's where it's going to be. Unfortunately, we're not going to have time to keep going back on this. We got a lot more people that are commenting. We're going to try and get to as many of you as we can. But if we can't, I'm sure Anthony would be more than happy to spend the next 2 weeks answering you.
Well, actually, I will say, I know oftentimes people want access to the slides. So if you want, I mean, I have a full slide deck that's like 80, 90 slides that, and at the bottom of different slides, there's oftentimes links to the relevant resources and stuff. So you could click on these links.
Let me go into this. Anthony, would that be a link to your resource that we could put people on our YouTube channel? So if people want access to it, they can go to our YouTube channel in the description and get it?
Well, basically, it's on my on our company website. So if you go to priapta.com, you scroll to the bottom, you can download a PDF version of all the slides, and you can kind of look at it through there. Yeah, just for your reference, if you want all of the slides.
Perfect.
This is exactly what we hoped for, right? Anthony, is more questions.
No, I enjoy actually having it more conversational. I do a lot of presentations where I spend a full hour just plowing through the slides.
Well, let's keep going through some of these comments and questions. Some of them are more comments than questions, but you know what the heck, this is what it's all about. All right, so Kathy Ayers is where we left off. Paul Eck mentions pellet stoves. Mikkel, listen to this. Awesome data and explanation, Anthony, from YouTube. Thank you very much for joining us today. All right, moving. Kathy, what's that?
Is Greg Ugaldi tuning in from Twitch, or is he at an IBS pre-conference?
My guess is he's this is winter conferences, so I haven't seen him pop in, but that doesn't mean he's not listening.
It's a thumbs up when you watch this tonight on Dave Cooper Live Netflix.
Yeah, listen, if you guys don't know, every once a month, we are lucky enough to have the immediate past chairman of the National Association of Home Builders. He is the one that updates the president on what's happening in housing. Whether you like whatever president's in there, doesn't matter. He's still the person that gets to do it, and that's an honor in my opinion. And I think with that said, definitely tune in. But yeah, it's we got IBSX coming up in 2 weeks. And I'm going to plug myself. Hey, listen, we are, I'm actually doing my Tech Bite speech today. We're recording that. And I am going to be hosting several other events to include interviewing Mark Farmer for the International Builder Show. And we're going to be doing some panels. So I'll be hosting your panels as well. IBSX is going to be a lot of fun, and we're having a great time being part of it. So, all right, Anthony, let's get back to it here.
Yeah.
Dun, dun, dun. All right, here we go. Julian Bowen again. Corn-based biomass is an environmental nightmare. Pesticides, herbicides, fossil fuels used for production equals almost no benefits. Which thoughts?
I haven't looked into it specifically, but I know I've heard that, yeah, there can be the environmental equation does not look as favorable. That's it, but I don't know the specifics. Yeah.
Well, there is organic farming out there, so that biomass is a totally different equation.
Let's keep working through. Paul X says, like burning garbage. I'm assuming he's answering Julian. Let's see. Going down.
There's a lot of energy to be harvested from burning garbage. Don't forget that.
Kathy Allers. I mean, she's in it today. Embodied carbon. Does it count the energy inputs in growing the food that the construction workers eat?
No, that's a good point. So, where do you actually draw the line, the system boundary? Theoretically, you could actually go all the way through that, right?
Right.
But no, it doesn't. And that's just, where it's a limitation of how hard is it to gather this data and all that sort of stuff. So yeah, it mainly just focuses on the materials that actually make it into the building. There's actually, there are some phases of that life cycle graph that I showed you of like all those different stages. There's some stages of that we actually don't have really great data, and we need better data. So for example, even on the installation and construction process, which is where that would come in, like the workers that are kind of helping build the building, actually all the energy used there and the emissions associated with that, we don't have great data on that. So some of the tools either exclude that or they address it, but in a very, very simplistic way. Like, I know some tools like look at the mass of all the materials that go in and they assume that it's going to be lifted up a crane half the height of the building or something. And like, that's like a proxy, but we definitely need better data on that stuff. But from what we've seen, typically those numbers are fairly low. It makes up a very small percentage of the whole pie, but I think we would need better data to understand that.
Yeah. We need to have an award, Mark, for people that have the most comments between Paul and Kathy, Paul Eck and Kathy Ehlers. They're getting participation awards today for sure.
Well, the world requires participation, right? You could certainly watch, but action is it's welcomed.
I love it. All right, heading across the pond, Henry Mickelberg. I've suffered many embodied carbon presentations, but this one is almost enjoyable.
I appreciate that.
That's great. That great.
I thank you, Henry, for being able to keep it to a one-line statement versus the other ones that twinkle in my eye, right?
Normally, Henry can write something. It'll take up the whole page, and you can just see our eyeballs. I love it. Not short on words. All right, Rob Hoskin pumping his own company a little bit, but that's okay. BAG, speeding the transition to a zero carbon economy. Anthony's work sounds like a big part of it that we're not experts at.
Yeah, no, I appreciate that. And I think this is it's not just your company. It's most companies actually aren't, right? And I think it's a critical point right now. If you think about, it may not be mainstream or common practice right now, but think about all the efforts that we put towards operational carbon, all the expertise, all the knowledge, all the stuff that we've developed in-house in different firms around that, and all the products that are out there on the market that address this. I actually think this is like a huge area for, as a competitive advantage, if you want to look at it that way, for your design firms, right? So, it's kind of like Sean introduced me and said, like, I was like this expert or whatever. And, I'm one of the few people that actually can just devote all my time towards this. So I dig pretty deep into it. But that said, like, I'm only a couple of years into this. It's not like we need to build up a lot more knowledge on this front. And I think given the importance of this and the kind of where everything's going, I would say if you're trying to figure out how to sell this to your firm, this is actually a huge area for potential like differentiation, whether you're talking about specific projects, you're actually addressing this aspect, like this half of the equation that people don't address, or even within your firm, how you develop that competence. But yeah, I'm very passionate about helping people on this. So, you know, if you guys have projects where you want to look at this, reach out to me. We try to actually make, when we work on a project, to be kind of an educational experience for a lot of the design team members, because it's not just like whoever brings us onto the project, it's like all the consultants, right? And I think that's the only way that we really transition this as quickly as possible. So
Rob is a friend. He's an energy expert, and in the coming weeks, he will be presenting a BS Friday Live.
Love it. Rob, Anthony, you guys need to connect. I can already feel the love. All right. Jordan Daniel says, thinking about deconstruction and salvaging building materials for reuse, is there a way to quantify the additional embodied carbon after a material's first life? If so, is deconstruction and reuse advantageous from an embodied carbon standpoint as opposed to downcycling or using new materials?
Yeah, so no, reuse is definitely, I think that's the best scenario, right? Because you're actually extending, it's servicing a new lifespan. So typically the way we account for that is for the next lifespan, for like the second generation product that's going to be reusing this material, they actually get a free pass on, you know, like the A1 to A3 emissions associated with like the resource extraction, transportation, and processing for the materials that go into that component. So there is a benefit because like that part of the equation doesn't get accounted for in the second phase. But the question is, how do you assign benefit to the first building that's putting in the efforts to make it more easy to deconstruct those materials, for example? And so that's why I mentioned that module D, that supplementary information, is because it'd be hard to fully account for that in your main results, but we do report that separately because, and yeah, in general, when you're building buildings, try to think from a deconstruction standpoint, how easy is it to separate these materials out so that they can actually be appropriately put towards different waste streams, whether it's for recycling or reuse, especially for reuse. So that's something that's, you know, if you have a lot of composite materials, that's going to be hard at the end of life. You would have no idea of how they would separate that material. That's going to be a challenge at the end of life. So
for a steel structure, if it's cold connected, there's no reason that those connections cannot be undone. If it's a fiber building, screws come out the way they come in. But if you weld, exactly, you have a different application for the steel. And then if you nail and glue your wood, well, that's going to be a bummer. So those are just simple statements. But there's some great technologies out there that really are just fit like a glove. And they're designed for next gen use, and I really applaud those groups that certainly are not ready for scale, but are disruptors in their own right, because they put the planet first, they put the people first, and they're still a profit.
Totally,
love it. I mean, these are great questions. Kathy's back at it again. All right, let's see what Kathy Ehlers has. Solar shipping, isn't that what Magellan used?
I don't know the reference, but
just laugh. That's what I do, Anthony. You just got to laugh. When you don't know, you got to fake it, man. No, yeah.
Magellan like Magellan, right?
I love it. I love it. Henry Mickelberg, our study showed that shipping 3,000 sea miles was the equivalent to 400 U.S. trucking miles.
Yeah, that's probably, I mean, I don't know the numbers off the top of my head, but yeah, that's probably in the right order of magnitude. It is a significant difference.
Henry, my calculations show 402 trucking miles. So you're close, brother.
Yeah. All right. Love it. Love it. Love it. All right. Let me get going here. I lost my spot. A bunch of questions came in and it jumped. Give me 1 second. Coming.
Dave just likes reading the names of all the cool kids out there.
There is a lot of cool kids. A lot of cool kids. You know who I just saw actually was Adam popped in here. And that's what I was looking at. And then a bunch of new ones came in and we jumped all over the place. So give me one. There it is. All right. Adam says, what is your personal favorite project using these methods?
Personal favorite project using the, like projects that I've worked on, I guess.
Yeah, sure.
What's the, I don't know that I have a favorite, but I know right now, like we're working on a, I mean, I can't say the specifics of the project, but yeah, there's like a hospital project that I'm working on right now. And, you know, we're digging a lot into the details of like the concrete mixes in the building. And we're really like looking at the cost side of the equations and like practicality side. And we're engaging the contractor, which is really interesting to me. So it's not just like the structural consultants, and they have a whole different tier of knowledge. I feel like I'm learning a lot on the concrete side of things about like how they construct it and how high they can go on the supplementary cementatious materials, so like fly ash or slag in there. And, you know, where we can optimize it. So one of the cool strategies that actually came out from one of the recent presentations that we hosted at the CLF Vancouver, actually just was it last week? We had some structural engineers from the States give a presentation, and they presented this strategy. And like the next day I actually deployed it on one of our on this project to recommend it. And it's like a serious thing that we're actually looking at. It's like looking at, hey, maybe for the above grade slabs, typically they don't allow, people don't want to go very high on the SCM percentages because it affects the curing time and it affects all that. But maybe on the top level, we could actually go higher. So on that front, you know, because on the roof or the top layers, we don't have the same kind of construction scheduling requirements. Mm-hmm. And so, you know, that was something that I didn't think about before. It makes perfect sense, but I think, you know, we're getting into more the nitty gritty details of those strategies. Yeah, so that's just a recent example that came.
Anthony, I think it's important to say you're welcome back to the table. We didn't get to every slide, yeah, and we're thankful that this topic is engaging for the audience, mm-hmm, because it needs to be embraced. So please share the slides. Yeah, this is all about sharing. As Anthony just said, he learned something from a fellow and applied it the next day. We hope that you share this and apply it to the marketplace and the municipalities and the third-party groups that are engaged on your projects from the beginning of the projects.
Yeah.
Yeah, for sure. And Anthony, there's just no way with the time. We've already been at this an hour and 10 minutes, and the questions are pouring in. So I do feel the rest of your day is going to be answering questions. But what I do want to do is just acknowledge the people that are putting these questions in. We got a lot of people, you know, Jolene Bowen, Paul Eck, Andrew Seeley, Susan Rowley, Kathy Ehlers. I think I'm saying that right. Carmel Pratt. We weren't able to get to your question, but we will answer it. Has quite a few. Mirko Farnatani has a question. Said, "Thank you very much, Anthony, David, Mark." So he was thanking us. Quite honestly, there's no thanking Mark and I, Anthony. you're clearly the Rolodex of data right there, my friend. Joseph Hagerdorn, and I'm sure there's a bunch of people in the likes that have put likes on, but. Listen, Anthony, we really appreciate everything. And I'll take the link to your website as well, and we'll put that in our YouTube channel. So we'll put it up there so people can find that. It's also going across the ticker below. That way people can download this presentation. And as we said before, this presentation will live on YouTube. So please go to our channel and subscribe. There's a playlist called BS Friday. Go to it. Check it out. You can watch all the episodes there. And it usually takes about 12 to 24 hours before YouTube gets this up on the channel for us for whatever reason. I don't know why.
I invite everyone next week. Chris Ballard, Anthony knows Chris. Chris Ballard is up presenting next week. Every week we're live with a different guest. We know we can't cover everything. There's a lot of embodied content in Anthony's background, and if you haven't heard Chris Ballard talk. He has no political background, so you'll hear none of that whatsoever. But I invite you to join us next Friday.
Yeah, I think we have an opening in the next couple of weeks. I know we're pretty booked out, Mark. Let's bring Anthony back on. There's a long ways to go here. And I think maybe we do a special episode. Maybe we do a 2-hour commitment. I'm serious. You know, Anthony, listen, we're gonna maybe this is a BS Friday happy hour with drinks and people can show up with a beer after work, you know, and sit there, and we can take questions and talk, and we can bring Sean St. O'More back in, because he's the one that understands how to run all this BS and beer stuff. So we'll steal from you guys on that one, because Sean, you guys do this after party stuff quite often, and so I'm not taking from you. I'm just joining you, brother.
Hey, man, we got to celebrate all this fun stuff. And I mean, Anthony has just done a great job of dealing with that embodied, like the beginning part, and then typically the passive house takes care of the operation. And so both topics work very well together. And this is why kind of most people that end up at our happy hours are also paying attention to the Carbon Leadership Forum stuff too. So it's a great mix of good topics.
Yeah, really is. All right, everybody. Go ahead, Mark. You gonna say something?
No, I thank you for being here, Anthony, and we appreciate everyone that joins. Sean, Dave, it's been a wild ride. We're back next Friday, folks.
I love
Thanks,
it.
everyone.
All right, Anthony, don't go anywhere. Sean, don't go anywhere. We're going to do our outro. Listen, everybody, we really do appreciate you. Please hit that like and share button one last time, and please subscribe to our YouTube channel and follow all of these guys. They're a wealth of knowledge and a lot of fun. So that's it for today. I'm Dave Cooper. We'll see you tomorrow for Coffee with Dave, where we will recap everything that happened this past week, plus talk about what's coming up next week. Bye, everyone. Have a wonderful day. We'll talk to you soon. I don't have a coffee mug in front of me. We'll see you. Bye now.